Hear me?
Morning. Hi, Shinyan.
Hello?
Hello.
Hi, Herman. So, hi. So, how have you been?
Good.
Go.
Well,
Okay, good. Yeah, it's in the morning, right? All right. Hi, Victory.
Hi, Shunyan. Good
Yes,
morning. How are you? Can you see
morning.
me?
Yeah, morning.
Uh,
All right. So
okay. Okay.
let's get started. All right.
Okay.
yes.
All
I
right.
will.
So yeah.
Uh,
So Victor, go ahead. Yeah, please.
All right.
Yeah,
No-
thanks.
Okay. If you don't mind, I'm gonna share a PowerPoint screen.
Okay,
So
sure. All right, sure.
so what I'm
So
trying to do now is based on our last conversation. Sorry, just hold on. Based on our last conversation, I decided to create basically a PowerPoint screen. I mean a PowerPoint presentation where
oh,
uh, I want to summarize the problem as best as possible. Something I can print and put on my wall and sort of just see every
that's a
day.
good idea.
Okay, it's like anyways, but I wanted to get your opinion
that's great.
before I
Okay,
like.
okay. Yeah,
Okay,
go ahead. Yeah, that's
okay,
excellent.
all right. So first, I started with the problem. Um, can you see this,
Yes,
or
yes,
should I
it's
make it
better.
Yes.
bigger? Okay.
Yes.
Oh, okay. So first, the problem is, well, there's a huge rise in networking devices being used, smartphones, smart devices, basically anything that has a sort of routing protocol or anything that uses networks. Also, this rise has led to more demand. I think that I should put that more demand in resources such as more cloud servers, for example, better communication systems, more efficient server systems, or more dynamic networking environment. Also, there's a challenge with uh, higher financial requirements when scaling up. So the
Okay,
idea is
okay. All right.
as the as the
Okay.
server usage or computer usage increases, the cost sort of increases. Um, so why it's a problem? Well, it's a
Oh yeah,
bit of
by
a
the way, you can
repetition.
add sensors. You can add sensors to the computing devices. That's another big one. Sensors.
Oh, okay.
Right.
Sensors.
Actually, yes. I
Yes.
mean, smartphones and sensors. Actually.
Oh, yes. 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 Okay. Okay.
Okay.
Okay.
All right. All right.
Smart
Next.
that.
Sorry. Yeah.
Smart. Yeah. No, that's fine. Um, So, well, it could pose it could pose huge financial challenges for both service providers and users when scaling up. So, at the current rate of growth, if it continues at this scale, it's going to be a big problem for service providers like Google, because now there's more demand for their cloud computational services. More competition means more cost, and again, for them to provide it, it's expensive for them, and for the users, it's also more expensive. It could also pose an environmental risk. I think we talked about this on Tuesday, where to build a new server farm, you need, to cut down more trees in the Sahara somewhere, just so it can be away from residential areas. And also, current models use, I don't know if this is a thing though, I called it semi-centralized approach. It's not fully centralized, but at the same time, there's like major data centers, such that if a big data center was to have, say, physical failures or data loss, major data losses, then they could lose a lot of data because a lot of information was in that server farm. Um, I don't know if this is making any sense so far. I'm just gonna continue.
Yeah. So I mean, so
Okay.
the data centers typically have redundancy. So they would have systems. I mean, because I mean, you can think if you're like Amazon or Google, this would
Yeah.
be of slight concern to you. So typically, so they do have systems in place where they basically have offsite
Like
backups as well.
backups. Yeah.
But yeah. But as you can probably imagine, I mean, it is a problem to move all that data and have backups of all that the whole time. I've got a colleague who works for Amazon, and he says when their servers are down, then major meetings are held at all times of the night. So
Jeez.
just having servers go down it is a big problem for the big data centers. But that's also maybe a criticism, or maybe a counter argument is the argument of, okay, but because if you go decentralized as we're planning on going, essentially the big corporations are losing control of all this data, and they might not like that. So although I saw there is a movement in Europe which basically, actually, I think Tim Berners Foundation actually has started some new, I don't know if it's a routing or an internet paradigm, where the idea is basically that the control of the data is back in control of the users, instead of that it's in the control of the companies. If I find that link, I'll send it on to you.
All right. So,
Please continue.
all right. All right. I think I'll find a way to reward this to sort of reflect those. All right. Also, so the proposal, I just put this on one slide because I couldn't really think of anything else. But the idea is to basically create a decentralized spatial routing system. And this system will be based on vast P2P algorithm, right? Or should I call it library? Let me say library.
The algorithm is called VON, VON, Voronoi Overlay Network. VAST is the implementation.
Oh,
the algorithm is called VON, VON.
Jeez. Oh yes, that's what is in the papers. Okay. Just mark that red. Sorry. All right, that's fine. Okay.
Yeah, you can fix this later. Yeah, but just,
I'll fix this later. Yeah. Anyways, so now for the aim, right? The aim is to develop an open source algorithm for both users and service providers. So basically, the idea is both the user can use it. They can basically go on GitHub, for example, and apply it to whatever context they might require, especially when it comes to data management and that kind of thing. It should also be able, Google should also be able to use it if they want it, in terms of, okay, they can apply it to their existing systems and sort of build on top of that. I don't know if they would want to do that though, but the idea is it should be open to all. Also, the aim of the algorithm is to sort of efficiently distribute data across a network. I used web because basically it's like a web of devices, but I think network sounds more technical. So, but the aim is to effectively or efficiently distribute data across a network. This is to efficiently distribute resources to minimize the risk of data loss or delays, and also to provide a scalable model. So the idea is on this, using this algorithm, you can use as many devices as possible. Again, for our test, I know we said 1,000, 2,000, but I do think that should just be used as a test and not necessarily the final. It should be developed.
Oh yeah, obviously, the final should not have any limit.
Limit, yeah, it shouldn't have a limit. So the idea is to provide it such that it can be scalable, it can be used for maybe even
to millions of devices,
yeah.
to millions of nodes.
Yeah, without it crashing, or without losing data as well, or reducing the amount of the data loss rate. And also the API affords the users the opportunity to develop lower cost routing systems. So again, the whole idea behind the algorithm is anyone can just look at it and be like, okay, I don't want to pay Amazon Cloud, subscription fees every month to if I can convince users to share their phone resources, then maybe I can build my own system, something like that. all right, to develop
Okay.
lower
Yeah.
cost. Yeah. And the next steps, basically, first is the literature study of existing works. So this literature study, that's what sort of forms the survey paper that we talked about. That's going to be the survey paper. That's like the first main, maybe conference publication. And the idea is also to develop an API for simulation. I'm guessing this should be VON algorithm. That's the right one. And basically, after developing the API, or should I say in the API development, there should also be a development of performance metrics. I think we've already discussed what the performance metrics would be. But one thing Professor Hammond talked about I think it was last week, where he said we should find a way to develop measurement algorithms as well, how to sort of measure, for example, latency in the code. There should be like a sort of small piece of code or function that does the measurements, and then to basically experimental implication. Implementation in an industrial environment. So in this case, the nuclear environment. The idea is how would it work how would it work in a real life scenario, and how would the results compare to our experiment, or should I say simulation values rather. How would the simulation values compare with the practical, or should I say experimental values, and what caused the discrepancies, right? Is it the radiation? Is it walls? Is it network? Stuff like that. Just those are the
Okay.
things that will be analyzed when implementing the experiments in the industry. So yeah, but yeah, that's basically it. I'm not sure if I missed anything.
Okay. Great. So Harman, you like to feedback?
Well, I mean, I like the fact that you've already made the presentation, because that basically means you're putting your argument on paper, and it means you can now go and refine your argument and tinker on this part or tinker on that part. So I think I like that already. And I like the idea of putting it up on your wall where you can see that the whole time and think about it. I think your next steps is, but that's in broad strokes, basically the rest of your PhD. That's good. I would. So one thing you can do is when you speak to other people, for instance, like Karsten or Shunyun or myself or Baitzang or whatever, I think you should ask people to poke holes in your argument. Ask people, okay. No, really. I mean, like, okay, so why is this not correct? Why what am I missing in this argument? So that can help you to strengthen the argument. So if people tell you, okay, yeah, that what you say there is true, but you didn't take the following into consideration, then that can help you. In the end, you're going to have a PhD defense. And there is a very good reason why it's called a defense. And that's because you need to defend your argument.
Yeah.
It's like, it's literally like it can be seen as a court case where you're saying, where you're giving someone's going to give you a counter argument. And then you have to say, yes, but the following. So that's the one thing, you must basically live and breathe this argument for the next 2 years or so, and so that I would definitely discuss these people and ask them, okay, but poke holes into this argument.
Okay. I think I'll do that.
That's a great feedback. Actually, start to leave the defense from now.
Yeah.
So when the actual defense comes, you'll be more than natural to respond anyway.
Yes. Okay.
Okay. Any other feedbacks?
So open source algorithm, that's good. I mean, the measurement is So I think that's something that you probably need to build in right from the start. I think because my experience has been that if you develop the algorithm and you then try and slap on the measurement as well, that's usually when you have to jump through interesting hoops to make everything work. So I'm just saying that when you develop the algorithm, already start developing the how you're actually going to measure the latency and the throughput and all those kind of things, so that you put that in right from the start. The one thing I think I would now actually go and start to now dig deeper into these various things. So instance for that API development for Von and Vast. So, okay, let's take that and then basically pack this out in the same way that you did this over here. So, okay, I want to do API development. Where do I want to end up with? What's the, and how do, and then basically work your way backwards to where you are at the moment.
Okay.
So that you can figure out what's the necessary next steps in order to do this. We are having that mastermind tomorrow morning at 8, and
Yes.
I've got a master's student who's actually working on. He's basically taking the peer-to-peer persistency architecture that my first PhD student proposed, and he's basically he tested it in simulation, and this student was basically implementing this so we can actually test it on a real, real hosts. So he's hopefully going to be joining tomorrow. He's actually sitting in Amsterdam or somewhere in the Netherlands at the moment. And then I've got a yeah. And then I've got another. I mean, he's a South African student who started studying, and then halfway through his studies, he moved to the Netherlands. And then I've got a colleague of mine who's now getting involved with IoT for the agriculture, and he's going to be joining tomorrow morning as well. So I sent an invite to you guys this morning. You might have received it.
Yes.
I just used the Zoom link that we've always been using as the invitation because I figured that's what we'll use. Yeah.
Yes.
So then tomorrow morning at 8, we'll have about 5 people there, and then I think it should be an interesting discussion.
All right.
Cool.
Great. Thanks, Armin.
Yeah, that's
All right.
awesome. Thank you.
So I guess I'll provide some feedbacks. Okay.
All right.
The first thing is that I like the overall structure and the layout, and also like Carmen said, it's written down and in a presentation format. That's very, very good. The one small thing I think would add tremendous difference in terms of letting people understand the context of the work and the importance is to just add spatial in front of every word when you mention data.
That's true.
Okay?
That's quite true.
Does that make sense?
Okay.
Does that make sense?
Yes.
Okay.
Yes, it does.
The reason what I mentioned is if you're just talking about data in general, like database, like IT systems, like forms and all that, right? There are very, very mature database technologies, scaling algorithms, or sharding, all that data management things done for decades, okay, of work. That makes scaling them no longer really an issue. Okay, I mean those are not new problems. However, if you're talking about spatial data that's going to be produced by an expected large increase in the the devices, mobile phones, sensors, and robots, all these things, IoT, right? Then you see that's a different story. We are not just expecting simply data to become larger. Everybody knows that, but we are expecting the amount of spatial data to explode in the coming years. Okay? And currently, there may still not be good enough ways to manage them. Most of the management database or algorithm, they are more or less centralized. Okay? And I think you can check into the literature, and I think you will find this statement to be more or less true. In the sense that I think it's still pretty hard and sophisticated to do good partitioning of the data for spatial data. Okay.
Okay.
Because for example, just one example, to store things on a map, you could use something called like a quadtree, or an octree, to
Okay.
basically put them into a binary tree. Okay.
Yeah.
However, that kind of management, it requires a centralized data structure to do the partitioning. And also it may not be very dynamic and easy to adjust. Okay. The other thing is that when you're talking about dynamically moving data points, okay, like cars, vehicles, and all that. Okay, so Uber is a good example, right? That has a lot of thousands, tens of thousands of moving vehicles that it needs to track, right? So those are moving data. That again requires approaches to handle. And because of that, right now, probably only Uber has good system and algorithm to handle that, not everybody else. Okay, and like that MySQL is the most popular open source database, but I don't think it handles spatial data well. Okay, at least not on a large scale. Okay, see, so there you go. You see, so that's a very real problem. In that there's no, and this is true from industry perspective as well. I don't think there exists common, cheap, affordable, tools or approach to manage spatial data in an affordable way.
Yeah.
Okay. I think most of the approaches, or at least if they're good systems, it probably will cost a lot.
Yeah, probably.
Okay.
So I think if you present this, or if you discuss this with people who are, relatively familiar with networking and with spatial data and things like that, I think the first question someone will ask you is also, okay, but doesn't GIS, solve this problem already?
Exactly.
And I think you then you must be able to say, GIS is used for, static data. It works quite well, but and you must just verify what I'm saying now. But it doesn't handle dynamic data, for instance, or the problem of real-time data, and also quite possibly it doesn't have. It's still a centralized approach, so that scalability is potentially a problem.
Exactly. When you're talking about millions of data points on maybe on a global scale, then right now I think most solutions that could handle that kind of data volume are still pretty proprietary and expensive.
All right.
Okay. I think you can do a little bit of study. That's probably true. Okay. Because in the past there aren't that many spatial data to handle it, right? Okay. This is a new phenomenon that is only enabled by mobile and sensor devices. Okay. So that's the first feedback. Okay. And the second is that I still feel that it would greatly help if you can paint or present a sort of a vision of one slide on the vision of what this should look like. Like what's the ideal scenario if there's an ideal solution that exists, right? I think you already talked about this last time in our thing about you will be able to build your own Uber service or anyone for that, right?
Okay.
I think that kind of possibility and scenario you should have a slide to paint that.
Okay.
Okay. That serves two purposes. One is that I think it will help people to easier to understand and grasp the application side of things easier, right?
Okay.
Otherwise, it's kind of like abstract. You talk about there's data I need to collect, I need to scale, but like why?
I see what you mean.
Why would I do that, right?
It's a bit vague.
Right? But if you're talking about, right, how about if your colleague, your friend has a idea to build his own Uber fleet, without relying on Uber's infrastructure, right?
Okay.
Or without a different Uber service, right?
Okay.
And that doesn't require as much capital, which Uber actually burns through a lot of capital to achieve
Yeah.
its current scale and success. Then right, that could be a more compelling story, especially
Okay.
given you can add more colors to this. Like
Okay.
we are entering a world where delivery service will become increasingly important, right? Especially
Yes.
with conditions like COVID. That's a very real scenario, right? I mean,
Yeah.
people may not be able to travel as much as humans, right? Or as far as much as in the past. Physical movement could be limited, but
Okay.
the transportation of goods, that's still needed, right? So a lot of things. In fact, this is already on the rise. If you look at like Uber Eats, right? You can maybe find some data about like the growth of like service like Uber Eats and
Like service
like
delivery,
Foodpanda, right?
Yeah.
I mean, it's exploding everywhere.
Yeah.
Right? I mean,
Especially
that's
after
a
COVID.
real demand right there
Yeah.
in terms of delivery services of all kinds of goods and services of different
Okay.
quality of service or different price levels. You see, and if we just have a few providers, the big giants, that's not going to work. You see, and they're going to monopolize the market.
Yeah.
So if there is a cheaper,
Okay.
affordable infrastructure and solution for that, that will really improve the people's quality of life and choices, right?
Okay.
I think if we want to move to a world also where we have all these autonomous vehicles, I mean, where you literally have a drone coming to deliver your package or whatever.
Exactly.
I mean, those type of vehicles and systems will need to have real-time dynamic access to this type of spatial information.
Exactly.
Otherwise they're going to crash or not deliver it to the wrong place or whatever. So
Yeah.
Okay, and you can even imagine a bit like these devices, they may not all have access to some centralized control center, to have the most accurate spatial data, right? If they're operated in some remote locations, potentially they may be on their own, and they might need some kind of spatial routing algorithm and approach that is decentralized.
Okay.
Right?
Okay.
You see? I guess what I'm trying to say is try to move the picture, just think a bit further ahead, 10, 20, 30 years down the road, right?
Okay.
When there are a lot more devices, a lot more autonomous vehicles, robots, deliveries, right? And that's the world we're entering. And what kind of infrastructure, right? What kind of open source tools will be needed, right?
I think I know what.
Do they exist? Do they exist now? And
I don't.
The answer is no, right?
Yeah.
Right? You see?
Yeah.
That's the argument.
Exist,
Okay, that's and that would also allow people to better understand both the application usage scenario and also the importance of the work.
Okay.
Okay. Does that make sense?
Yes, it does. It does.
Okay. All right. Okay.
Thank you.
I guess hope that helps. Okay.
Yes,
so I guess any other final questions?
For now, no. I've not received a response from with Sang yet. I think I'll send it again, but this time I'll just copy. I'll copy Professor Herman. This time.
Okay. Did you CC to Herman as well?
No, you
so
did not.
The last one I did not. Yeah, but I'm gonna send it now, and then I think I'll send it today.
Okay. All right.
And then copy.
All right.
Herman as well.
Okay. So I guess refining the proposal, but also the conference target. Okay. I'd like to see that next time when we see.
Okay. Conference.
Okay. The submission target. Yeah.
Okay.
All right. Okay. So I guess that's it. So we'll talk tomorrow then. All right. And,
yes.
8 a.m.
Cool.
Mastermind.
Yes.
Okay.
Yes.
All right.
Okay.
So thanks.
Thank you,
Thank
sir.
you.
Talk later.
Thank you.
Okay.
All right. Yeah,
Bye.
Bye.
Bye.